Okay, so we are going to talk about circles and arcs. First of all, we're going to break it down to all the parts of a circle. So I'm going to draw a nice big circle. I'm kind of cheating by tracing something, but it will still work. Okay, so a circle has a center. And when we are talking about a circle or naming a circle, let's say that this is circle P. So that is going to be the symbol for it. Circles are, by definition, it is a set of points equidistant from a given point and I forgot a key phrase, and that is right here. It is in a plane. I do that every time. They have to be in a plane, because if they're not in a plane, then we're talking about in space. So if I have a set of points equidistant from a given point, so if I'm talking about the plane of the paper, all the points equidistant would give me all of these points all the way around, which creates the circle. If I take away in a plane and put in space, that's what creates your three-dimensional stuff, and then you get a sphere instead. So circles are labeled with a symbol, a circle with a little point in it, and then it's always the capital letter, which is the center. Excuse me. So we have this piece, which is called a radius, and the radius is a segment from the center. I'm going to abbreviate center, CTR, center of the circle, to a point on the circle. And there are a whole bunch of radii. So if I draw the same thing over this way, that is still a radius. Okay. If you have more than one radius, you do not say radiuses, you say radii. If I have a chord, a chord is a segment. You can see the green segment whose endpoints are on the circle. So we have an endpoint on there and an endpoint there. Then we have a special chord that goes through the center. And this is called a diameter. So this is, let's see, diameter is a chord that passes through the center of the circle. Okay, and just let you know, the diameter is the longest chord in any circle. If you notice, there is a relationship between the diameter and the radius. So this much is a radius, and this much is a radius. So there is a relationship between the diameters and the radii. So we could say that a diameter equals 2 times the radius, or a radius equals half a diameter. Okay? I think I'm going to draw a separate circle to talk about arcs. Okay, so do that for a minute. Cheat by copying another one. So we have circle P, and we have a radius. So I'm going to label it small r. If I have another radius, okay, so I have a radius and a radius, this actually forms an angle. So this is called a central angle. It's an angle whose vertex is at the center of the circle. And its sides are radii. This right here is called an intercepted arc. So by definition, an arc is part or a piece of the circle. Okay, and the reason why it's called an intercepted arc is because if I were to extend the sides of my central angle, it's the arc in between the sides. If I have a, well, let's see, I'm going to extend this radius out. So I'm making this one big diameter. So if I have a diameter, okay, so this is a diameter D, half of the circle, is called a semicircle. Okay, so half of a circle is called a semicircle. And then we have different size of arcs. We have a major arc, and we have a minor arc. A minor arc is labeled with 2 points on the circle, and a major arc is labeled with 3 points on the circle. Okay, so I'm going to draw like a separate little circle here. So if I have points D, C, C, A, and this is circle P, and I'm going to make this a K and an F. Okay, absolutely no rhyme or reason. If I'm talking about a major arcs need to be greater than 180 degrees. Minor arcs need to be less than 180 degrees. And semicircles we're talking about are equal to 180 degrees. So I am specifically going to draw a diameter. I'm going to label this as E. So if I am talking about a minor arc has to be less than 180. And just like lines or segments, they have their own special symbols. So some minor arcs for this diagram, I was talking about this piece here. I can say that that is arc DF. Load up a little bit. Okay, so I have arc DF. I could be talking about this one, and say arc EK. So notice I'm putting a little arc symbol up there. I could be talking about from D to C. I do not list the A because I know from D going all the way to C, it is clearly less than half a circle. So I could say arc DC as well. Now, if I am talking about D to C going all the way around the circle, if I am talking specifically about going this way, that is clearly greater than 180. So I would have to use the 3 points that I had talked about. So I'm starting at D, and I'm ending at C. And then what you do is you just have to label one of the points that you're passing through. So I could say DFC, I could say DKC, or I could say DEC. And I'm just going to pick a K. And then just like the other ones, there is an actual arc symbol. Okay? So if I have a major arc, and I'm talking about from A, going through all of these points, traveling to F, I would say arc A, EF maybe. Okay, the point that you're passing through doesn't matter, but this is where I'm starting the arc, and this is where I'm stopping the arc. When I'm labeling a semicircle, you still have to use your 3 points. Because if I just say arc DE, you don't know if I'm traveling this way or if I'm talking about this part of the circle. So again, you have to use those 3 points. So I could say arc DAE. So if I say arc DAE, that means I'm starting here, traveling through A, and stopping at E. Okay, we're going to stop there with the parts of a circle.